in this section, we're going to talk about what we call the common ion effect. And what it does is it causes Le Chatelier to come back and cause a shift in dissolving of a solid. So you saw with your lab that some salts, very little actually dissolves, that a lot of it stays as a solid, and we're going to see what happens to the solid and what happens to the ions. So in this first example here, they want to add some extra stress to the above reaction, and really this should be a double arrow. So by adding extra stress, will add extra chlorine or maybe extra silver ion, and they want to know what's going to happen to dissolving of the silver as a result of this. So when you have what we call a common ion, so that means that there is silver or maybe chlorine ion already dissolved in the solution. We need to figure out what happens to the equilibrium. So equilibrium shifts to offset the stress that is added in the form of a cation. So we're talking about Ag plus, or an anion like Cl minus. Now, if you remember from Le Chatelier, if we're adding something to the product side, which is the dissolved ions, that is going to shift things to the left. So as a result of it, equilibrium will shift to the left. So what does that mean? That means that there's more solid present. And what does that mean? That means less of the solid will dissolve. Now, if we were actually in the lab, we could do this. We could see that if we added a common ion, that it would cause more solid to fall out of the solution and actually form at the bottom of the container. So you could probably look up on YouTube a video of that. Okay, so the question is, what does this mean qualitatively? Oops, sorry guys. Okay, so if less of the solid dissolves, the solubility of each ion decreases. So that means less cation or anion dissolves. And in this section, you're going to look for the common ion. So you're going to see, is there a cation that is shared with the solid that's trying to be dissolved, or is it the anion? I'm sorry, I'm misspelling here. Okay, so we're going to do an example together. So here we have solid silver chloride, and notice that they tell us that there is present 0.01 molar sodium chloride. So notice that chlorine is shared with silver chloride, so that is the common ion. And they want to know how many moles of silver chloride will dissolve if you have 1 liter of this solution. Okay, so we're going to assume that NaCl will completely dissolve. And you're probably like, what do you mean? Well, that means that sodium chloride is one of those solids that will completely dissolve. So if we have 1 liter, we're going to have 0.01 molar of chlorine ion. Now, once again, you have to draw out the chemical dissolution of silver chloride and make sure that you get the ion charges right and the stoichiometry right. Now, luckily, it's 1:1. Now, because this is a solid, we don't care about any of the concentrations. So we know that that doesn't factor. We're going to assume that there is 0 silver ions in the solution because notice that it's sodium chloride. None of the silver has dissolved yet. And under chlorine ion, we're going to put 0.01 molar. Okay, so when you talk about the change, it's going to be plus X here. And the equilibrium is going to be X, and this is going to be X plus 0.010 molar. Now, we can do something interesting here to help with figuring out the solubility. So we're going to assume that X is very tiny compared to the chlorine ion. And as a result of it, it is going to go away. So when we set up our equation, we're going to do this. So KSP equals silver ion times chlorine ion. And luckily, there's no exponents that we have to worry about. Now, the KSP is 1.8 times, so 1.8 times 10 to the negative 10th. And we're going to make silver X, and we're going to make chlorine just 0.010, because we're assuming that this X is tiny. So we're going to ignore it. And we're only ignoring it for the chlorine ion. So when you solve for this, X becomes 1.8 times 10 to the negative 8th. So notice that that is the solubility of silver. Okay, now notice at the bottom here, the solubility of silver chloride typically is 1.3 times 10 to the negative 5th. It is tinier because we added this concentration of chlorine ion. Okay, so whenever you have common ion effect, it causes the so it's causing the solubility to decrease. Okay, I'm going to do one more problem with you, and then I'm going to let you try the last one on your own, and then I will share the answer key with you. Okay, so for the second example here, we have calcium ion, and notice that we have calcium fluoride, but in addition to that, we have 0.2 molar of KF. So once again, we're going to assume that KF fully dissolves into potassium ion and fluorine ion. So we're assuming that the common ion is fluorine. And we're going to assume that the concentration of fluorine is 0.2 molar. Okay, so once again, we have to set up our dissolution equation. And you have to pay attention to stoichiometry. So once again, we have the double arrows, and we have calcium ion plus 2 fluorine ions. So this is a difference than the previous problem. So once again, we don't care about calcium fluoride because it is a solid. And we're going to say initially there's no calcium ion dissolved. However, there's definitely 0.2 molar of fluorine ion. We're going to say plus x and then plus 2x for this. And then at equilibrium, we're going to call it x. And then we're going to say here I'll do 2x plus 0.2 molar. Now once again, we're going to assume that 2x is smaller than 0.2 molar. So what does that mean? We're going to set up our KSP. Sorry, I'm running out of room here. Now remember that it's squared, okay? So you got to make sure that you square it. Otherwise, if you don't, you're not going to get the right answer. So I'm using the KSP from above, and I'm going to say x times 0.20 squared. And when I solve for x, I get 0.103 times 10 to the negative 9th. So you could say that calcium has a concentration of 0.03 times 10 to the negative 9th. Okay, so go ahead and do example 3, and then I will share the answer key with you. And if you have any questions, just reach out to me.